Hello, welcome to my YouTube channel Physics for All. I'm Dr. Abbas and today we will teach Coulombs law. In this video, we will discuss about the type of charges, the significance of Coulombs law, and then we will discuss some examples related to Coulomb law. Using Coulombs law, we can calculate the electrostatic force between two point charges placed at some distance. Okay, let's move towards our lecture here. First of all, we will discuss the type of charges. Benjamin Franklin was the first person who introduced these types known as positive charges and negative charges. Usually, the example of positive charges is proton, or if we want to produce it, we can rub the glass rod with silk and we can gain positive charge. On the other hand, if we talk about these negative charges, electron has negative charge. But if we rub the rubber objects, we can gain this negative charge as well. There exists a fundamental law of electrostatic. It explains that like charges repel each other and opposite charges attract each other. In the base of this fundamental law, the law, this attraction and repulsion between charged bodies have many industrial applications. It includes paint spraying, powder coating, fly ash collection in chimneys, and in photocopying and printing as well. Okay. The last thing is principle of conservation of charge. According to this law, charge cannot be created and not cannot be destroyed, but merely transformed from one system to another. Okay, the next is the statement of Coulomb law. This law actually states that the electrostatic force between 2 point charges is proportional to the product of the charges and inversely proportional to the square of the distance between them. For example, if you assume two charges Q1 and Q2 placed at some distance, if there could be three cases. If both charges are positive, they will repel each other. If both charges are negative, they will again repel each other. But if one charge is positive and other is negative, as we can see here, they will attract each other. So in this attraction process, they will apply force. So for all these three cases, here we have the forces. Here F force with subscript F12 denotes that the force exerted by charge particle Q2 on charge particle Q1. Similarly, in first case, if both charges are positive, they will repel each other. In the second case, if both charges are negative, again they will repel each other. But if we have one positive charge and other negative charge, they will attract each other by applying this force F12 is the force applied by charge Q2 on charge Q1, and this force F21 is force applied by charge Q1 on charge Q2. Okay, so the mathematical expression for Coulomb's law is this expression states that this electrostatic force F can be calculated by this product that has the charge Q1, charge Q2 divided by R cube. This R cube, R square, sorry, this R square is R is the distance between both charges. And as we know, this force is a vector quantity. So here we place a unit vector and this K is a constant. So using this relation, when we know the amount, the magnitude of charges, we can calculate the force and their direction as well. So to calculate the magnitude, we just drop this unit vector from this relation as we can see here. So we have F is equal to K Q1 Q2 over R square. So in this relation, we can see that The electrostatic force, also known as Coulomb force, is directly proportional to the product of the charges Q1 and Q2, and it's inversely proportional to the square of the distance between them. So these are the key parameters. And further, in many notebooks, we will find this relation as F is equal to 1 over 4 pi epsilon naught mod of Q1 mod of Q2 over R square. Here, this Q1 and the reason for applying this mod is our charge could be positive or negative. But as I earlier said, it was just mentioned by Benjamin Franklin. So actually, we does not present the magnitudes with negative numbers. So here we put this mod. And this constant K has the value 1 over 4 pi epsilon naught. Its exact value depends upon this epsilon naught, that is the permittivity of free space. Its value is 8.85 multiplied by 10 power minus 12 Coulomb square per Newton meter square. If you put this value above in this relation and replace this epsilon naught, you will find this 8.89 multiplied by 10 power 9 Newton meter square per Coulomb square. Both of these quantities K and epsilon naught have these opposite units, and if we want to drive these units, we just need to use this relation F is equal to K Q1 Q2 over R square. For example, if we want to find the value of K, we took this R square on the other side, it will be multiplied with F, and we divide Q1 and Q2. So this R square will give us meter square, force is in Newton, so it will be Newton meter square, and Q1 and Q2 both are Coulomb, so it will become Coulomb time Coulomb, Coulomb square. So here we can see K is equal to Newton meter square per Coulomb square. And epsilon is inverse, so when we will inverse this, we will find it Coulomb square per Newton meter square. So using this relation of force, we can find the magnitude of force. This force will be along the line connecting the charges, and this force could be attractive or repulsive. It depends which case we are considering from our three cases. It could be positive charges, negative charges, or positive or negative charges. So after this mathematical expression, now we discuss the principle of superposition. So far, we have discussed that these electrostatic charges interact in the form of pair. So this is a situation where we have more than two charges. We assumed n charges, in fact, with different amount of charges. So if we have to solve this problem, how we can apply Coulomb's law on this situation? So to solve this complex problem, we will apply the fundamental concept of Coulomb's law that states that charges, the static charges, interact in the form of pairs. So if, for example, we want to find the net force F1 net, which is the vector sum due to all these charges, so it will give us the net force will be the vector sum of F12 plus F13 plus F14 up to plus F1n. So this is the total force acting on charge particle Q1 due to all these n charges. Okay. So here we will discuss an example for 2-point charges. In this example, we have assumed 2-point charges Q1 and Q2, which are separated by distance capital R, and they are placed on x-axis. So if we see the statement, we have 2-point charges that are separated by 5 meters, and if the charges have the magnitude 2 Coulomb and 5 Coulomb, what is the magnitude of force between them, and is this force attractive or repulsive? Okay, to find this, solve this problem, we first arrange the data. We assume that Q1 is 2 Coulomb, Q2 is 5 Coulomb, and the radial distance capital R is 5 meters. So we have to find the force. To do this, we will use the mathematical expression of Coulomb's law, which states that this force could be equal to 1 over 4 pi epsilon naught Q1 Q2 over r square. Now at this moment we have defined q1, that is 2 coulomb, q2 which is 5 coulomb, and this radial distance is 5 meter. So we put all these values including the value of 1 over 4 pi epsilon naught, which is merely 8.99 times 10 power 9 Newton meter square per coulomb square. And now all these units in red will cancel each other. Here we have coulomb times coulomb, here we have coulomb square, they will cancel each other. Similarly, this meter will cancel with meter square with meter square, and we will obtain only Newton. And as we know, the unit of force is Newton, so we will obtain this result. Once we simplify these simple calculations, we will obtain the force that is 3.596 times 10 power 9 Newton. Okay, so we move on with another example. So sorry, we had one thing more, that either this force will be attractive or repulsive. So in the beginning we said like charges repel each other. So in this case, this force will be the force of repulsion. Okay, this is our second example. Again, we have 2-point charges that are separated by distance capital R. And let's see what the statement asks. What must be the distance between point charge Q1 that has the magnitude of 25 microcoulomb and point charge Q2, which has the magnitude of 50 microcoulomb, for the electrostatic force between them to have a magnitude of 5 Newton. So in this case, we are given the magnitudes of charges Q1 and Q2 and the magnitude of force, and we have to find the distance. So for this, again, we will rely on Coulomb's law for 2-point charges. And Coulomb's law states that the F is equal to 1 over 4 pi epsilon naught Q1, Q2 over R square. So when we will put these values, but before this, we have to put this necessary step where we replace the f with r square, they are interchanged. So now if we take the square root of this r square, we will find our required result. So for the first step, I have just placed the values of all these quantities: 1 over 4 pi epsilon naught q1, this is our q2, and followed by the force 5 Newton. And once we simplify it, we will find the r square is equal to 2.22 meter square. And when we take the square root on both sides, we will find the distance r is equal to 1.49 meter. So dear students, please verify the results of both of these examples. And in our next lecture, we will discuss electric field. Thank you very much for your time.